Good morning, all of you. In today's session, we are going to start with CSIR NET JRF Chemical Science, June 2014, Part C, Series 6, right? Earlier, we completed CSIR NET JRF Chemical Science of 2015, 16, 17, 18, 19, 20 academic year. Both the sessions, including June and December question papers of solved papers are available on the channel called World of Competitive Chemistry. And even in this 2014, all the part B and part C questions as well are made into different series, and each series consists of 10 questions in this part C of CSIR NET JRF Chemical Science, June 2014, right? So this kind of previous year standard question paper discussion will fetching you towards examination preparation, whatever you are preparing for. That may be entrance exam or competitive exam if you are aspirant about research. So in all these areas, it will be fetching to you. So let us discuss about today's concepts. CSIR NET JRF Chemical Science, June 2014, Part C Series 6 consists of questions from 121 to 130. Let us start with question number 121. A particle in one-dimensional harmonic oscillator in x direction is perturbed by potential lambda x. Lambda denotes it is a number. The first order correction to the energy of ground state will be, right? So for this purpose, a particle in one-dimensional box when considered, so perturbation energy term is proportional to x. Perturbation energy, this is the question from quantum mechanics, that perturbation energy of the given system, particle in the one-dimensional box is proportional to x. Then Hamiltonian harmonic oscillator empirical equation is given as h is equal to minus h square by 2m dou square by dou x square plus half kx square plus half bx, right? So h denotes what? Hamiltonian harmonic oscillator. H is equal to h naught plus h prime. First order perturbation theory, E prime is equal to m mod h m, right? Here, we can substitute the values of m here. E prime is given as psi naught x mod h prime psi naught x. So here, just to be substituted the values of m here, right? Psi naught x is equal to n naught e to the power alpha square x square by 2. So this is the value of what? Psi naught. Psi naught denotes what? It is the wave function. Then lambda denotes what? Number. And here h denotes what? Hamiltonian harmonic oscillator, right? So here n naught is root alpha by root x, and alpha to the power 4 is equal to mk by minus h square. H prime, the value is given as 1 by 2 bx, right? So if we substitute all the known values here, E prime is given as what? Psi naught x mod h prime psi naught x. So we will substitute the value of this h prime value. So E prime is equal to psi naught x 1 by 2 bx. This value we are inserting here. So h prime value is going to be incorporated and psi naught x will be as such. So later it will be taken as integration n naught e to the power minus alpha square x square by 2. So 1 by 2 bx n naught e to the power minus alpha square x square by 2 dx, because here psi naught value is given by this one. So just we are inserting psi naught value instead of this, instead of psi naught x. So when we substitute, the equation can be expanded in this manner. Later 1 by 2 bx a naught square, because here a naught same values are provided twice. That's why we can take the square of all these. So 1 by 2 bx a naught square integration e to the power minus alpha square x square into dx becomes 0. So for this system, particle in the one-dimensional box, first order correction of the energy is 0. For question number 121, option number 1 is the correct answer. Let us move on to question number 122. The point A, B in the following sequence of the reactions are. This is a part of organic chemistry where biomolecules is the topic. So we are taking 1, 2, 3, 4, 5, 6. 6 carbon chain, which is said to be a polyhydroxycarbonyl compound called carbohydrate. What is the definition of carbohydrate? Polyhydroxycarbonyl either consisting aldehyde or ketone is said to be a carbohydrate, right? So this is the carbohydrate moiety of glucose. D-glucose is the exact configuration of that one. And it is treated with methanol under acidic conditions and subjected to reflux conditions to 24 hours. What is mean by reflux? Reflux is nothing but boiling the solvent to its boiling point temperature. More than its boiling point temperature is said to be a reflux condition, and we are employing reflux for the period of 24 hours. That means 1 day heating is required for this D-glucose with this methanol under acidic condition, so that it turned into a compound A. Now it is treated with PHCHOMe taken twice. This is of 1 equivalent under again acidic conditions. Both the reactions are proceeded under acidic conditions, and we will achieve the final product here, right? For this purpose, let us see how we can achieve the final product. Let us see the entire mechanism. We are taking the starting material, which is said to be a D-glucose. D-glucose absolute configuration is measured here, RSRR. This is the absolute configuration. 2, 3, 4, 5, 6 pentahydroxyhexanol is the IUPAC name of this compound. Upon treating with methanol under acidic conditions subjected to reflux for the period of 24 hours, it turned into a methyl glucoside, right? What happens? It will be turned into a cyclic compound with this methoxy functional group. So here methyl glucoside will be generated here. Methyl glucoside is of 2 types. One is alpha glucoside, second is beta glucoside. Both are possible because here this is a prochiral center. When we add this methanol, there is a origination of this methoxy functional group is possible in both the ways. Anyway, we got methyl glucoside as the compound number A. Now it will be treated with PHCHOMe taken twice of 1 equivalent. Upon treating with 1 equivalent, here you can see that it is the kind of system where we have PHCH double bond O actually. Now the double bond aldehyde group is treated with dimethoxy. It is a kind of acetal. What is the molecule here? It is a acetal molecule. When this acetal molecule is treated with this methyl glucoside, what it will do? Methoxy groups now replaced with this hydroxy. There is a condensation reaction with these hydroxy so that one more cyclic product is obtained. Cyclic ether originated, it is said to be a bicyclic ring system. This will be the final product we will achieve by treating glucose with methanol and subsequently with this acetal compound. That is provided, where it is provided? In option number A, we got OMe in the equatorial position. This is not the suitable orientation for this. Here we got this, what we can say? Bicyclic ring system. This is second one is a correct only, but first one is a wrong one. So that should be in the axial position. So that is exactly provided in the option number 2. In option number 2, methoxy is inclined towards the axial position. It will be the stable conformation for this D-glucose, and subsequently it will be treated with the acetal, and there is a formation of bicyclic ring system, right? For question number 122, option number B will be the correct answer, right? Let us move on to question number 123. So it is a part of spectroscopy analytical methods. The mass spectrum of the product A formed in the following reaction exhibit M, M+2, M+4 peaks in the ratio of 1:2:1. The reagent HX and the product A will be, right? It is a question purely based on the mass spectrum of the given compound. We are taking molecular ion peak +2, molecular ion peak +4 can be taken. And when we consider these 3 peaks, they are in the intensity ratio of 1:2:1. Then what could be the reagent added HX and the final product A? For this purpose, we took the content from NPTEL lecture. The mass spectrum of product A formed in the following reaction exhibit M, M+2, M+4 peaks in the ratio of 1:2:1. And what will be the reagent HX and the product A? In order to get this, we have the table. This data is collected from NPTEL lecture, right? So here, if single bromine is there, there is a molecular ion peak of 100 abundance and M+2 peak of 98 abundance will be there. Only two possibilities are there and two peaks. So already we know if chlorine is there, there is a ratio of 3:1 abundance. 3:1 intensity ratio will be there. But bromine exists in two isotopic forms. Both the isotopic forms having almost equal abundance. One is 100%, second is 98%. So that the ratio will be 1:1. If two bromines are there within the compound, this is a typical thing from which you can find out the answer for this question. If two bromines are there within the compound, abundance of molecular ion peak will be 100%. Molecular ion peak +2 will be 195%. Molecular ion peak +4 will be 95%. The intensity ratio will be taken as 1:2:1 that they already provided within the problem, 1:2:1. This corresponds to what? The product should contain 2 bromine. If product contains 3 bromines, what will be the ratio? 100 of molecular ion, M+2 will be, M+4 will be 286, M+6 will be 93. So the ratio will be 1:3:3:1. So here there is no possibility because we are not getting this kind of intensity. If bromine and chlorine are there, because within the options they mentioned bromine, chlorine, bromine, chlorine, bromine, 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 bromine. All these possibilities are there. So that if bromine, chlorine is there 100, 130 and 32, these are the abundance percentage of molecular ion M+2 and M+4 respectively, and their intensity ratio will be 3:4:1. And this is also not applicable because within the problem they clearly mentioned the intensity ratio is 1:2:1. That is purely applicable to the compound containing 2 bromine atoms within the compound. 1:2:1 ratio for M+2 and M+4 respectively. So that from this data, we can clearly confirm the two groups are bromine atoms only. So option number C and option number D are having 2 bromine atoms within the compound. And whenever the starting material was taken, then we have to find out what could be the right answer. Either position alpha with respect to benzene or beta with respect to benzene. Where could we get this bromo substitution? In order to avoid this ambiguity, so here the starting material we have what kind of compound it is? It is the secondary hydroxy compound which is attached at first center, and the para bromo position will be there. It will be treated with HX. Let us assume it will be HBr because from this data it is confirmed that bromo is the second substituent. In order to get bromo substituent, we could have to add HBr. When HBr is added, there is a simple nucleophilic substitution with this OH group. OH will be replaced with bromo, and subsequently it turned into a bromo dibromo substituted compound. Dibromo substituted compound is suitable with option number C rather than option number D. Why can't we go with option number D? Because here beta substitution is there. In case of nucleophilic substitution, wherever we are discarding the functional group, in the same place we have to add the incoming group. So that will be available only in the option number C. So by this we can confirm that for question number 123, option number C will be the correct answer. Let us move on to question number 124. It is the question based on match the following. Match the following natural products in the column A with their structural features in the column B. This is a question from natural products. We are taking the starting material colchicine, strychnine, quinine, ephedrine. All these are the compounds which are naturally extracted, and their subsequent structural features to be mapped. It may be tetrahydroxypyr, phenanthrene, tropolone, phenyl ethylamine, quinoline, and benzofuran. These are the structural features of the compound. Some of the compounds will be exactly mapped with this one. Let us go with one by one. First is about colchicine. Colchicine is the natural product which is having 7-membered ring system. One is unsaturated, second is saturated, and here is the benzene ring and the amide group is there. What you can say? Colchicine is a named well-known tropolone alkaloid. It is a kind of system. So what is the main feature for alkaloid? system which containing at least one nitrogen is called alkaloid system. Here you can find a nitrogen within the molecule, so that it is said to be a alkaloid compound. And this is a system called tropalone alkaloid. So this is a system called tropalone alkaloid, isolated from being it is a natural product, always extracted from the plant material. Colchicine autumnally is the plant from which this colchicine will be extracted. These plants are widely employed for traditional medicines and still used in the treatment of gout disease. Gout disease is nothing but whenever our blood mixed with excess of uric acid, so that irritation tendency, burning tendency, and that will be inflammations will be possible. That is called a gout disease, which can be cured by the drug called colchicine, which is extracted from the natural plant called Colchicum autumnale, right? So this is a kind of system where a tropalone alkaloid can be employed. Tropalone alkaloid is provided in option number C. So colchicine, option number C is the correct answer. That is provided in option number A and option number D both. And next is about strychnine. Let us see what is meant by strychnine. Strychnine is the system which consisting such a indole type of moiety. Here you can see indole moiety, and here we have cyclic lactam system, and this is a system called a seven-membered ring. When seven-membered ring with oxygen, that is called oxypin ring. Seven-membered ring with oxygen is called oxypin ring, but more two pi bond should be present. That's why you can say it is the hydrogenated oxypin, means reduced form of oxypin, right? So here strychnine is a monoterpenoid. Terpenoids also another kind of natural products where all the products are made up of isoprene units. The essential moiety for terpenes are isoprene units. And here you can find indole moiety. Benzene condensed with the pyrrole is called indole moiety. Here indole ring is present within the structure. And tetrahydroxypin. Just now we discussed seven-membered ring with oxygen is called oxypin. And moreover, we need three double bonds. But only one double bond is there. That's why you can say tetrahydro. So more two double bonds got reduced. Tetrahydroxypin moiety it is. And strychnine bearing keto substantiated 10th position, right? So keto group is also present within the molecule. Here you can find the ketone functional group that is constituting at 10th position. It has a role as a avicide. Avicide is the drug agent which is synthesized from this strychnine and glycine receptor antagonist. So it used to retard the activity of glycine receptor, allergic antagonist, and rodenticide as a neurotransmitter agent. These are the medicinal properties of strychnine. So what is meant by rodenticide? Rodenticide is nothing but a rat and its related family. Microorganisms or animals can be treated by using this one. That used to retard this rat and its related family animals. And also neurotransmitter agent is nothing but, so in the human beings it used to stimulate the activity of the nervous system. In that case also this strychnine can be employed. And the most important feature for this one, tetrahydroxypin moiety will be there. So tetrahydroxypin is provided in the option number 1. For strychnine, option number 1 is the correct answer. Let us move on to quinine. What will be the quinine structure? This is the quinine structure. You can find the quinine structure where quinoline is the main moiety, and in either ring system is there with the nitrogen. This is said to be a pyridine ring, right? So being it is a saturated, you can say piperidine ring, right? So here quinoline and piperidine moieties are present within the molecule. This is a natural product again, quinine. So it is the very essential material nowadays. It can be treated for malaria, right? So quinine is the cinchona alkaloid. So cinchona is the plant from which quinine is extracted. So it is the kind of alkaloid system. Alkaloid is nothing but nitrogen containing nitrogen containing natural products are called alkaloids. Here you can find two nitrogen atoms. One is quinoline moiety and other is a piperidine moiety within the molecule. And at the 6th position, quinoline ring is present. Quinoline ring, you can find a methoxy functional group. The main purpose of quinine will be anti-malarial drug. It will be the anti-malarial drug and a muscle relaxant. So any muscular pains are there, those can be relieved by this one. So muscle relaxant, non-narcotic analgesic, which used to avoid any kind of pain conditions without inducing any addiction property. That is said to be a non-narcotic analgesic. Okay, so here wide applications are imparted from this quinine, which is extracted from cinchona bark. So cinchona outer layer, that is cellulose layer, from that you can extract this quinine, and which is consisting, there's a quinoline moiety within the structure. It is provided, quinoline is provided in the option number E, quinine being it is mapped with this quinoline. Ephedrine in either natural product material. Let us see what are the important features of this ephedrine. Ephedrine is the benzene derivative, and the benzene side chain will be there. What could be the absolute configuration? Here OH group is present on the alpha position, beta position methyl is there, gamma position NH group is there, and one more CH3 group is there. That is nothing but ephedrine is the system where the hydroxy secondary amine functional group. Either OH can be inclined towards the VR, otherwise away from the VR. Absolute configuration may be inverted in both the cases. Both are having medicinal properties. Ephedrine is also a medicinal property containing material extracted from the natural source. Let us see. It is a phenylethylamine. You can easily find how many carbons are there. 1, 2 carbons are there. And here this ring is called phenyl. So benzene ring with a short of 1 hydrogen is said to be a phenyl. So here phenyl, and being it is a 2 carbon system, ethyl, and here you can find amino functional group. So that the chemical structural feature of this one will be phenyl ethyl amine. So that is the main structural component of this ephedrine molecule chemically. It is an alkaloid. How can you say it is alkaloid? Again, you can find a nitrogen within the molecule. Nitrogen is an essential feature for alkaloid. So that you can find this is the compound called alkaloid system. Phenylethylamine skeletal structure can be found in this. And the plant from which you can extract this ephedrine means genus Ephedra. Genus Ephedra is the plant from which you can extract this natural product called the ephedrine, which is the medicinal property containing component. Ephedrine is a central nervous system stimulant, so which used to enhance the activity of the CNS, central nervous system, and used for the treatment of breathing problems. If any bronchio or bronchodilatory related or respiratory related problems are there, those can be easily cured by this. And nozzle congestion as a decognizant. Low blood pressure. So if any people are suffering from low blood pressure conditions, in that case also ephedrine used to enhance the blood pressure conditions. And also myasthenia gravis. This is another kind of disease. These are also cured by this ephedrine. So being it is a medicinal compound extracted from the natural source. What is the natural source? Genus Ephedra is the plant from which you can extract this one, and it is associated with phenylethylamine. That is a structural feature which is provided in the option number D, phenylethylamine. Ephedrine is mapped with this phenylethylamine. Let us see where all these options are correctly mapped. Colchicine is the system with the tropalone. This tropalone is provided in option number A and D. Strychnine, tetrahydroxypen. So 2 with A is provided in option number A, even in the option number D. Quinine is quinoline. So 3 with E is provided in option number A only, but not in the option number D. By this, you can confirm option number A will be the correct answer. And moreover, ephedrine will be with the phenylethylamine. 4 with D. All are exactly mapped in the option number 1. 124. For question number 124, option number 1 is the correct answer. Let us move on to question number 125. A particle in one-dimensional box, potential 0 between 2a and infinite outside, has a ground state energy E naught is equal to 0.12 pi h square by ma square. The expectation value of the Hamiltonian weather psi x is equal to x into x minus a yields energy E1. Using linear combination of two even functions, x into x minus a, x square into x minus a whole square, we obtain the variational maintenance to ground state energy E2. Which of the following relation holds for E0, E1, E2? What is the correct series of relation between the energies of ground state energy denoted with E0? First level excited state is E1 and second level excited given with the E2. So what is the correct series we have to predict, right? So for that purpose, this is a question from quantum mechanics again. A particle in the one-dimensional box, a potential 0 between A and infinite outside, which is provided like this. And what is the relation between E0, E1, E2 to be predicted? For that purpose, so one-dimensional box energy is provided by n square h square by 8 ma square. This is an empirical formula. So if we go with a ground state, so n can be taken as a 0 square h square by 8 ma square can be taken, and this is the formula in order to predict the energy of the particle present in one-dimensional box is equal to n square h square by 8 ma square, right? So based on this formula, if we substitute the given ground state energy, the correct series will be E0, E2, and E1. E0 will be least, and the next energy will be E2, and the highest energy is provided for first level excited state E1. That is given in the option number 2. For question number 125, option number 2 will be the correct answer. Let us move on to question number 126. The dissociation constant of the weak acid HX at the given temperature 2.5 into 10 to the power minus 5, pH of 0.01 molar sodium halide at the temperature is. This is a question from chemical equilibrium. Chemical equilibrium. So let us find the dissociation constant is given for this pH to be predicted. So for the given solution, pH of the solution, let us see. Dissociation constant of the weak acid HX is provided with 2.5 into 10 to the power minus 5. pH of 0.01 molar sodium halide to be predicted. For that purpose, the given compound is HX can be ionized into H plus and X minus. This is a general representation of ionization reaction of given weak acid, right? At the initial level, when we are considering the reaction at T is equal to 0, means initial initial time we are considering, so that here initially all the compounds exist in the starting materials, because dissociation not started. That's why all existing starting materials only, ionization will be 0 at that instance. So HX concentration can be denoted with C, and H plus concentration will be 0. X minus concentration also 0. So at the initial concentration, C is the concentration of HX, H plus will be 0, X minus will be 0, because all are existing as a starting material. Because just now we are going to start the reaction at the equilibrium. At the equilibrium, some extent of reactants got converted into this ionized form. At that instance, H plus concentration becomes C alpha, X minus concentration also becomes C alpha, because how extent of HX ionized, the same extent of H plus and X minus will be generated. That's why C alpha will be the equal concentration for X plus and X minus and H plus. And the leftover term will be 1 minus alpha, C into 1 minus alpha, right? So from 1 unit, what extent it got ionized, and the leftover will be C into 1 minus alpha will be the concentration of HX. So this is at equilibrium. Now, Ka dissociation is given by product concentration by reactant concentration. Product will be H plus concentration into X minus by HX concentration. H plus concentration is given as C alpha. X minus is also given as C alpha. HX concentration is given as C into 1 minus alpha. So that it will become, when they multiply these two, C square into alpha square by C into 1 minus alpha. Here we have C in the numerator and even denominator both get compensated. C get compensated, we will left over with 1C. C alpha square by 1 minus alpha. This is dissociation constant K is equal to C alpha square. So because you can discard this denominator term. Why denominator term is discarded? Because moreover it is present in the denominator. First thing, always denominator term will be less. And the alpha value is extremely low. 1 minus alpha becomes almost negligible. That's why we are discarding this denominator term. That will be neglected. So that Ka will become C alpha square. This is the dissociation constant of the given weak acid. Now alpha square is equal to, let us predict alpha square is equal to Ka by C. Alpha is equal to root Ka by C. If we remove the square, it will become root. Now alpha is equal to Ka value, dissociation constant is provided to us within the problem, that is 2.5 into 10 to the power minus 5. The value is root 2.5 into 10 to the power minus 5, and the concentration is provided as 0.01. Then we will get alpha is equal to root 250 into 10 to the power minus 5. Alpha is equal to 25 into 10 to the power minus 4. Alpha is equal to, you can, if you remove the root, it will become 5 into 10 to the power minus 2. This will be the value of alpha. Value of alpha. Now the intention is to predict the pH of the solution. Then H plus ion concentration is given as C alpha. Within the problem they mentioned H plus ion concentration is given as C alpha. That can be taken as H3O plus also. H3O plus is almost is equal to H plus only, right? So in the advanced chemistry, we can write H3O plus rather than H plus, right? So H3O plus concentration is given as C. Concentration is nothing but 0.01. Alpha value is given as 5 into 10 to the power minus 2. 0.01 into 5 into 10 to the power minus 2, that will be 0.05 into 10 to the power minus 2. This will be the concentration of H plus, nothing but concentration of H3O plus. Now, according to Sorensen, pH is equal to negative logarithm of H plus ion concentration. Just we will incorporate this value, pH is equal to minus log of 0.05 into 10 to the power minus 2. So if we take the log of this value, pH is calculated 8.3. So pH of the given solution can be calculated as 8.3. That is provided in option number 3. For question number 26, option number 3 will be the right answer. Let us move on to question number 127. The ground state energy of the hydrogen atom is minus 13.598 electron volts. The expectation values of kinetic energy and the potential energy in units of electron volts are. Here, hydrogen atom ground energy is minus 13.598, almost is equal to minus 13.6 electronic volts. They're asking for what will be the kinetic energy, what will be the potential energy, right? Total energy is given by kinetic energy plus potential energy. That is nothing but kinetic energy is half mv square. Potential energy is minus k into z e square by r. K denotes the proportionality constant, z is the charge, e square by r is the radius, right? So here, what they are asking for, expected value of these two. So here, kinetic energy is equal to potential energy. That is nothing but mv square by r is equal to kze square by r. Now it will become kze square by 2r. So mv square is equal to kze square by 2r it will be. So that value is given as minus 13.598 electron volts, right? So here kinetic energy value is provided as minus 13.598 electron volts. In order to calculate the potential energy, minus k into ze square by r is equal to. So this is the double quantity of kinetic energy, that is given by 2 into 13.598. So whatever kinetic energy is there, that can be multiplied with the 2, then you can obtain this potential energy value. That will be 2 into 13.6. So it is taken as, it is measured, mentioned with a negative sign, right? So it is taken as minus 27.196 electron volts. Kinetic energy is 13.59, potential energy is minus 27.196. Both are provided in the option number 1. T denotes what? Kinetic energy, because within the problem they mentioned the kinetic energy denoted with T, potential energy denoted with V. So T is equal to 13.598 and V is equal to minus 27.196. Both are provided in option number 1. For question number 127, option number 1 will be the right answer. Let us move on to question number 128. If psi is equal to 0.8 pi a plus 0.4 pi b is the normalized molecular orbital of diatomic molecule AB constructed for psi A and psi B, which are also normalized, overlap between psi A and psi B will be. Okay, so psi value is provided to us. Then what will be the individual psi A and psi B, right? Which of the normalized, the overlap. So how extent overlap between psi A and psi B, that to be predicted. So here psi A is equal to 0.8 pi A plus 0.4 pi B. So normalized wave function is given. The value is calculated as 0.31. That is provided in the option number 2. For question number 128, option number 2 will be the right answer. Next is about question number 129. It is the stepwise chemical kinetics. The question which is given from chemical kinetics. At the given temperature, consider Fe2O3 plus 3 carbon monoxide gives rise to 2 iron plus 3 carbon dioxide. It is denoted with first order kinetics K1 is equal to 0.05, right? And 2 carbon dioxide can be reversibly decomposed into carbon monoxide and oxygen, whose rate of the reaction is given by 2 into 10 to the power minus 12. Equilibrium constant for this to be predicted. What's the reaction to Fe2O3 called ferric oxide? Being it is solid, can be decomposed into 4 iron solid plus 3 oxygen. For this reaction, equilibrium constant to be predicted. Okay, so equilibrium constant is given by the product of K1 into K2. But the reaction can be taken in the stoichiometric form. If all are present in the stoichiometric form, then directly you can take K1 into K2. But let us see, let us first balance the entire equation so that we will go with the multiplication of these two rate of the reactions. So in order to get to Fe2O3 gives rise to 4 iron and 3 oxygen atoms, the entire equation here they given with only 1 mole, right? So in order to get these many, the entire equation can be multiplied with the 2. 2 into Fe2O3 3CO gives rise to 2 Fe plus 3 CO2. Now the equation, even rate constant also multiply 2 into 0.05. So in this way you can take. So for second one, where we need 3 moles of oxygen, right? Here only 1 mole is there in the starting reaction. Only 1 mole of oxygen got generated. In order to get the stoichiometry, entire equation of second one can be multiplied with the 3. 3 into 2 CO2 gives rise to 2 CO plus O2. K2 will become 3 into 2 into 10 to the power minus 2. So rate will be multiplied with the 3. K equilibrium is taken as K1 into K2, right? Now it can be taken as 2 into 0.05 into 3 into 2 into 10 to the power minus 12. It can be taken as 2 into 10 to the power 38. 2 into 10 to the power minus 38 is provided in the option number B. For question number 198, option number 2 will be the right answer. Let us move on to last question of the series. It is the question from energy sources, right? In the bomb calorimeter, the combustion of 0.5 grams of compound A pertaining molar mass 50 grams per mole increase the temperature by 4 Kelvin. If the heat capacity of calorimeter along with that of material is 2.5 kilojoules per Kelvin, the molar internal energy of the combustion in kilojoules is molar internal energy of combustion to be predicted in kilojoules. So the given data is W nothing but weight of the substance is 0.5 grams, molar is equal to 50 grams. If weight and molar mass both the values are known, it is possible to calculate number of moles. Number of moles is equal to weight by gram molecular weight. We will take the ratio 0.5 by 50. It can be taken as 0.01 moles. 0.5 by 50 can be calculated as 0.01 moles. Now, the question is molar internal energy of combustion to be calculated. For that purpose, delta U is nothing but molar internal energy change is equal to Cp into dT by N. Cp denotes what? Heat capacity. dT, change in the temperature. N denotes number of moles. Here, Cp value is provided, that is 2.5 kilojoules per Kelvin, and change in the temperature is provided, that is 4 Kelvin. By number of moles can be taken as 0.01. So if we go with the calculation of all these 2.5 into 4 by 0.01, it can be taken as 1000 kilojoules. 1000 kilojoules are provided in option number 1. For question number 130, option number 1 will be the right answer. By this, entire series of 6 of CSIR NET GRF Chemical Science June 2014 Part C was completed. I think this session will be helpful for your preparation. Thank you very much for your consistent listening. Thank you one and all.